Hi friends, today I will discuss armature reaction in the DC machines. First I will discuss definition, next purpose, next assumptions, next terms used, next armature reaction, next remedies for the armature reaction. What is the definition of the armature reaction? It is the effect of armature flux on the main flux. What is the purpose of it? To know the cross magnetization and demagnetization effect. Next, to know the remedies for the armature reaction. Assumptions. For simplicity, here I am taking two-pole generator. The generated EMF equation is given by phi Zn by 60 into P by A. The terms used here are geometrical neutral axis. This is also called the geometrical neutral plane. Second one is magnetic neutral axis or magnetic neutral plane. Trailing pole tip, leading pole tip, polar axis, Fleming's right hand rule, curl rule, armature current, armature flux, main flux, brushes, interpoles, compensating winding, demagnetizing flux, and the cross magnetizing flux. First, what is geometrical neutral axis? It is the imaginary axis which divides the armature core into two equal parts. So this is the north pole of the main pole, this is south pole of the main pole, and this is the armature position. This is the center point of the armature core. So that we can show like this. So it is the imaginary axis which divides the armature core into two equal parts. So that we can say here geometrical neutral axis. Next, magnetic neutral axis. It is the axis along which flux is zero and it is always perpendicular to the resultant flux. So look at this. This is your armature and it has the conductors. So these conductors from here to here and from to here, they cut the main flux, whereas the conductors here and here, they are parallel to the main flux. So there is no cutting of the flux. So there is no induced EMF in these two conductors. So it is the axis along which flux is zero and it is always perpendicular to the resultant flux. Next, trailing pole tip. It is the tip of the pole where the density of flux lines is more. So you can see here. So here the flux lines are more. Similarly here also flux lines are more. So this is called the trailing pole tip. This is also trailing pole tip. Next, leading pole tip. This is the tip of the pole where the density of flux lines are weak. So look at this. The flux lines density is less. Similarly here also the flux lines density is less. So these are this pole and this pole tip, they are called the leading pole tips. So if the armature rotates in the clockwise direction in the main magnetic field like this, the conductors which are lying under the influence of north pole will carry the current into the blackboard, whereas the conductors carrying the current under the influence of south pole carry the current out of the blackboard like this. And these conductors will produce the flux like this. Similarly here also the conductor produces flux like this. This flux line will add to the main flux lines, whereas this flux line will oppose the main flux. Similarly here the flux line opposes the main flux, whereas here it aids to the main flux. As a result, we find here formation of the trailing pole tip here and here, whereas leading pole tips are here and here. Next, polar axis. It is the imaginary line which joins the center of north pole and south pole. This is north pole and this is your south pole. So center of these two poles, this line we can say called polar axis. Next, Fleming's right hand rule. With the right hand thumb, forefinger, middle finger mutually perpendicular. If the thumb shows the direction of the motion of the conductor, forefinger shows the direction of the flux, then the middle finger shows the direction of the current in the armature conductor of the generator. Here you can see here, this is the main pole, north pole, and this is the another pole, south pole. The flux emanates from the north pole and ends at the south pole, and the conductor is moving upwards. The current conductor movement or motion is represented by the right hand thumb like this, whereas the forefinger indicates the direction of the flux lines. The flux lines flows from here to here, so the forefinger indicates the direction of the flux. Now the middle finger, which is perpendicular to this finger and this finger, indicates or shows the direction of the current induced in this conductor, that is out of blackboard like this. Next, curl rule. If the fingers of the right hand are curled in the direction of the current, then the thumb indicates the direction of the flux produced like this. So this is the current direction. The fingers are curled like this, then the thumb indicates the direction of the flux produced by this current. Next, armature current. It is the current flowing in the armature. Armature flux. It is the flux produced by the armature current. Main flux. It is the flux produced by the main poles. Brushes. These are the brushes which slides over the commutator segments. Interpoles. These are the small poles mounted to the yoke between the main poles. These poles carry few turns of thick wire connected in series with the armature winding and carries the armature current. Next, compensating winding. It is the winding placed in the pole face of main poles and connected in series with the armature winding. Next, analysis of the armature reaction. The armature reaction can be described or analyzed in two parts. When the armature carries current, the other is when the armature carries no current. That is, when the armature current is zero, when the armature current carries current. So first, when the armature current is zero, like this, only main poles are there. So main flux is there. So no armature flux, which we can see here. So we represent that main flux like this, here to here, Fm or phi m like this. When the armature current is zero, there is only one flux produced by the main poles and it is perpendicular to the geometrical neutral axis, while the brushes are placed in the magnetic neutral axis, which is also coinciding with the geometrical neutral axis as shown in the figure. So armature carries no current. Then, so here you have the conductor. This is another conductor, and this is the magnetic neutral plane. This is also called geometrical neutral plane. They are coinciding, and it is possible only when the armature current carries no current. Next, when the armature carries current, and this can be analyzed in two parts or in two stages. One is when the brushes are at the geometrical neutral plane. The other is when the brushes are at the new magnetic neutral axis. When the armature carries current, this will be the situation. So as I said earlier, when the armature rotates in the clockwise direction, the conductors under the influence of north pole carries the current into the blackboard, while the conductors under the influence of south pole carries the current out of the blackboard. So we are placing brushes at the geometrical neutral plane. When the brushes are at geometrical neutral plane means here like this. When the armature rotates in the clockwise direction under the influence of north pole, armature carries current into the paper while the armature carries current out of the paper under the influence of south pole, as I said earlier. This armature current produces flux perpendicular to the main flux. It is called cross magnetization flux. This we can see here. So already main flux is there, that is OFM. So now you have the armature flux OFA. So because of the two fluxes, now we find what is called the resultant flux due to the armature flux and main flux. And the direction of the resultant flux is like this. This is your main flux, this is your armature flux. Resultant is like this. Due to this, magnetic neutral axis shifted to the new position. So because magnetic neutral plane is always perpendicular to the resultant flux. Resultant flux is here now. The perpendicular to this means this is the new magnetic neutral plane. Earlier it was here, means coinciding with the geometrical neutral axis. As a result, some of the conductors which were under the influence of north pole comes under the influence of south pole and vice versa. Now the conductors at geometrical neutral plane generates voltage. So earlier at geometrical neutral plane there was no voltage because the magnetic neutral plane was also here only. Now the magnetic neutral plane changed from here to here. So now these conductors comes under the influence of north pole, whereas these conductors comes under the influence of south pole. Then the voltage induces current. Now the conductors which are in the geometrical neutral plane are no more in the magnetic neutral axis. So they are under the influence of the north pole. So they produce a voltage. This voltage induces current in the brushes. So this leads to spark over around the commutator. This armature flux distorts the main flux, leading to the formation of the trailing pole tip and leading pole tip at the pole faces. The resultant flux vector of armature flux and the main flux is shifting magnetic neutral plane from geometrical neutral plane by an angle theta as shown. That you can see here. This is your geometrical neutral plane and this is your new magnetic neutral plane. So shifting from here to here, so by an angle called theta. Then what is the advantage of this? No sparking at the brushes. When the brushes are in the new magnetic neutral plane, what is going to happen is no sparking at the brushes. Then what are the disadvantages? Armature flux becomes the resultant of the demagnetizing flux and cross magnetizing flux vectors. That we can see here. So when the brushes moves to this position, then there will be two fluxes. One is cross magnetizing flux, the other is demagnetizing flux. Then we can see here better diagram. When the brushes are at the new magnetic neutral plane, the, these conductors carry the current like this. Similarly, these conductors carry the current like this. These two conductors are responsible for producing the demagnetizing flux, whereas these conductors are responsible for producing the cross magnetizing flux. So there is this and this is this, and this is the main flux. So with the shifting of the brushes to the new magnetic neutral plane, additionally we are getting the demagnetizing flux. The nature of the demagnetizing flux is to reduce the main flux. Cross magnetizing flux is already there. So this the demagnetizing flux ultimately reduces the generated EMF in the generator, that is this. So once the flux reduces means automatically generated EMF reduces. Then the effects of the armature reaction. Cross magnetization flux distorts main flux. Demagnetization flux reduces the main flux. Resultant flux contains the harmonics, increases the iron losses because of increase in the harmonics. Then generated EMF reduces in case of generators. In case of motors, the torque is reduced because the flux reduces means automatically torque also reduces. Then brush shifting angle changes with change in armature current. Next, bad commutation, sparking at the brushes. Next, increased cost of main field winding. Remedies for the armature reaction. Compensating windings, interpoles, Chaffer poles by increasing the field current or MMF. First, let me discuss the compensating winding. Compensating winding is connected in series with the armature winding and is kept in slots of main pole faces. These windings carry the armature current in the opposite direction to the current of the armature winding just below the pole faces to nullify the cross magnetizing flux. Interpoles. These are the small poles fixed to the yoke between the main poles to nullify the cross magnetization. These poles are wound with few turns of thick wire. This winding is connected in series with the armature winding to carry the armature current. Interpoles follow the polarity of leading pole tip in case of generator, while in case of motor it follows the polarity of the trailing pole tip in the direction of rotation of armature. So as I said, compensating winding and interpole winding, they are connected in series with the armature. Chaffer poles. So by increasing the air gap between the armature and the trailing pole tip, reluctance increases, means the flux density reduces. In other words, uniform flux distribution occurs between the main poles. Next, by increasing the field current or MMF. So by providing the separate source to the field and increasing the field current, we can nullify the demagnetization flux. So here we can see the compensating winding position. So this is the main pole, north pole face. This is the south pole, main pole. Its face is here, and here we are placing the compensating winding. Here also we are placing the compensating winding. Here armature carries into the blackboard, whereas in the compensating winding the current flows out of the blackboard. Similarly here, exactly opposite to the direction of the armature current, we find the direction of the current in the compensating winding, and they are placed in the pole faces of the main poles. Next, interpoles. So these are the small poles placed between the main poles. This is your north pole and this is your south pole of main magnetic field. And armature is rotating like this. So in case of generator, it follows a polarity which is same as the main pole in the direction of the rotation, which is ahead of it. That is this. So here comes south pole. Similarly here, so ahead of this, the main pole polarity is north pole. So this also gets the north pole polarity. So whereas in case of motor, it is exactly opposite. So this is the main pole. This is another main pole, and here we are using the north pole, and the direction of the movement of the armature is clockwise direction. This north pole polarity is same as the main pole which is behind it, that is north pole here. Next, the shape of the main flux, main MMF, resultant flux, we can see here. Main flux is alternating square wave. This is the main flux, alternating square wave. Whereas the armature MMF is alternating triangular wave. Alternating MMF. Armature MMF shape is triangular, which are alternating in nature. Then armature flux is alternating saddle waveform. So that is this. This is the armature flux waveform. Next, a resultant flux follows the what is called the trapezoidal form like this. Thank you.